Hello, and welcome to this presentation, Getting Started with the EVS1000 AF Time Domain Mode. In this presentation, we'll show you how to make audio frequency time domain measurements using Rohde and Schwarz EVS1000 series analyzers. This presentation assumes a basic familiarity with Rohde and Schwarz EVS1000 series analyzers. If you're unfamiliar with the EVS, or if you'd like a review, you might want to watch the presentation Getting Started with the EVS1000 General Overview before continuing with this presentation. Software option K2 enables the EVSg1000's time domain analysis functions. These work in a way very similar to a traditional oscilloscope. The measured signal can be either the demodulated RF input or the low-frequency baseband input. Note that low-frequency signal input also requires option K7. Some common applications of AF time domain analysis mode are finding phase and level deviations in ILS and VOR signals, as well as analysis of carrier plus sideband or suppressed carrier sideband only signals. To access AF time domain mode on the EVSg1000, simply press the Mode Hard key on the front of the instrument and select AF time domain. If operating the EVS over VNC, press M and then use the down arrow to scroll through the list of available analysis modes. The first step in time domain analysis is entering the frequency in Hertz. To change the frequency or channel on the EVSg, press the Channel Frequency Hard key and enter in the numeric value. In VNC mode, use the keyboard shortcut Q to enter the frequency. Audio frequency time domain measurements can be performed on either RF or LF signals. The input signal type is selected using Config. On the EVSg1000, the RF connector is located on the front of the instrument, and the LF end uses a BNC connector on the rear of the instrument. Again, recall that option K7 is required for LF signal analysis. The first configuration setting in time domain analysis is Amplitude, the settings for which are accessed using the Amplitude Hard key or the VNC shortcut W. Amplitude is expressed in terms of percentage values of the RF level, in this example, minus 50.62 dBm. With grid max set to 100%, the top line corresponds to the RF level. And Y% per division is the size of each marked division step on the display. These values can be modified to change the vertical scaling. For example, by changing the value of Ymax to 40% and Y% per division to 10%, we can reposition and zoom in vertically on this VOR signal. Measurement time scales the x-axis and is accessed using the measurement time key or the VNC shortcut D. Measurement time is given in units of seconds, or rather the amount of time represented by each of the 10 divisions on the x-axis. In this example, each division is 2 milliseconds, so the entire screen represents a total of 20 milliseconds. We can change this setting to zoom in or zoom out of a signal horizontally. Here, we've increased time per division to 10 milliseconds in order to see more cycles of this time domain waveform. Similar to how an oscilloscope functions, measurements in time domain mode are made each time a trigger event occurs. There are three types of trigger modes. Normal means that a measurement is made only on a valid trigger event. Auto is similar to normal, but will also trigger periodically if no trigger event occurs. This can be useful when trying to determine the proper trigger level. And single only triggers one time when an event occurs. The source of a trigger event can either be the measured level or an external signal supplied via the trigger-in connector on the rear of the EVS. If level is used, this is specified as a %. The direction or edge of a trigger defines whether a trigger occurs when the signal rises through or falls below a threshold. And lastly, a trigger offset can be used to make the trigger occur before or after an event takes place. Let's look at an example. Trigger settings are accessed using the Trigger Hard key or the VNC shortcut K. Here, the trigger level is set to 30%, with a rising or positive edge, so a stable waveform is seen on the screen. If the trigger level is increased too high, no trigger event is seen, and the result is an unstable signal. Markers can be used to get numeric values from points on a trace. In time domain mode, 4 markers are available, and these can be used to obtain either absolute values or values that are relative to other values, the latter being so-called delta markers. On the EVSg, the cursor keys or rotary knob can be used to place or adjust markers. So in summary, AF time domain mode provides measurements of either power or voltage as a function of time in a way similar to how an oscilloscope operates. This functionality is enabled by software option K12. Analysis can be performed on demodulated RF signals or on low-frequency or LF signals if the K7 option is present. In both cases, the first step in performing time domain analysis is setting the input type and frequency. Then, parameters such as amplitude, measurement time, and triggering should be set appropriately. And finally, markers can be used to obtain numeric values for points on the trace. This concludes our presentation, Getting Started with the EVS1000 AF Time Domain Mode. If you'd like to learn more about the EVS1000 or other avionics-related topics, please see the links in the video description. Thanks for watching.